Gonna hit enter, and you'll see that DNS spoofing is enabled. So let's go to the target and try to go to live.com and see what happens. And as you can see, live.com, it actually uses HTTPS, and it has been redirected to our own website saying simple text, obviously. But as I said, you can have this in here. You can install anything you want. You can ask them to download something, or you can have a fake page and steal credentials or whatever you're looking for. It can also be used to serve fake updates to the target person. For example, there is so many uses to DNS spoofing. So this is just the basic case of how you can do DNS spoofing. And then you can use it and combine it with other attacks or with other ideas to achieve really powerful attacks. In this video, I'm going to show you how to use Man-in-the-Middle-F plugins. Now, before using these plugins, we have to downgrade a library called Twisted that comes pre-installed with Kali because it's not compatible with Man-in-the-Middle-F. So, I'm gonna first of all remove the one that's already installed by doing rm-rf usr lib python 2.7 dist packages, and the library name that we want to delete is called Twisted. As you can see, we got no errors, which means the command got executed properly. And the next step is to install the Twisted version that is compatible with Man-in-the-Middle-F. So we're going to do this by doing pip install twisted equals 15.5.0. So all we're doing here is we're using pip, which is a package manager for Python, to install a package called Twisted. So I'm going to hit enter. And as you can see, it's telling us that it's successfully installed. So now we can use Man-in-the-Middle-F plugins. And before doing that, I'm going to clear the screen and just run Man-in-the-Middle-F --help. And as you can see, we have a number of plugins that we can use once we're the man in the middle. Now, before testing these plugins, I'd like to note that they should work against both HTTP and HTTPS. However, according to online reports, it might fail when testing against HTTPS because Man-in-the-Middle-F seems to have issues with injecting JavaScript in HTTPS pages. It never happened to me, I'm just going by reports. So I'm not sure if it's because Man-in-the-Middle-F itself or if it's because the people just did not know how to use it. Anyway, there is a more reliable method of injecting JavaScript in HTTPS pages, but it requires programming knowledge. Therefore, I only cover it in my advanced network hacking course and in my Python hacking course. If you're interested in that, then check out the bonus lecture, the last lecture of this course, for more information about these courses and a comparison between all of my other courses that you can take with this course. With that being said, let's go and test these plugins against both HTTP and HTTPS. So we can inject JavaScript code using the inject plugin, and we'll have a look on that later on in the course. We'll have a full lecture on that. We can also inject a keylogger, and we'll have a look on this later on in this lecture. And you can use the screen plugin right here to take screenshots of the loaded pages on any computer that is connected to the same network. So let's have an example of this. So what I'm going to do is I'm going to use the exact same Man-in-the-Middle-F command that we've always been using. And the only thing is I'm going to add --screen to load the screenshot plugin, which will take screenshots of every loaded page. You can also add --interval to specify the interval in seconds between screenshots, but I'm just going to keep this to the default, so the program is going to take a screenshot every 10 seconds. So I'm going to hit enter, and I'm gonna go to the target computer. Now, like I said, you will get the best results if you test this against HTTP pages. Therefore, I'm going to go to a HTTP page called vulnweb.com. And I'm gonna go for any of these. So let's go for test ASP. And maybe just go on the forum here. And now, if we go back to the Kali machine, it should have taken screenshots of these pages. So I'm gonna go to another desktop. I'm gonna open my file manager. And we're gonna go to the location where Man in the Middle F stores the screenshots. So you can either press Ctrl and L from your keyboard, or you can click in here, not on the search, click on here on the title bar, press a /, and as you can see, you will see the path bar opening up for you. And you wanna go to var log Man in the Middle F. And as you can see, we have the screenshots here. So if we open this, you'll see this was the page that was loaded. And if you keep going through them, you will see the other pages that we loaded. Now, let's go and see if this will work against a HTTPS pages. Like I said, it should work, and it actually works for me, but a lot of people have reported issues. So we're gonna go to CNN.com. Again, this is a website that uses HTTPS by default. You'll see that it's automatically getting downgraded to normal HTTP. And when testing this, make sure you delete the browsing data before you test it, just to make sure that the web page is not gonna load from the cache and from the offline data. And let's go back to the Kali machine and see if we got a screenshot of this. And sure enough, here, if we double click this one, you can see this was a screenshot of the page as it was loading. But if we wait 10 more seconds, we will actually get another one because the plugin is taking a screenshot every 10 seconds. Now, let's go back to here, and I'm gonna Ctrl-C to quit this to stop it from taking screenshots. And the next plugin that I want to show you is the JS Keylogger. So again, we're just removing the -- screen, and I'm gonna type JS Keylogger. I can't really see why you'd want to use a keylogger in the page, because we can just sniff the data. But in any scenario, if you ever needed to use a keylogger, then you can use it this way. And let's go to another website. So let's go back to our HTTP website, vulnweb. And maybe let's click on the first result here. And maybe in the search, we will just search for test, and see if this is. So keep in mind, I actually didn't submit anything now. So if you are sniffing, you wouldn't actually see this yet until I submit it. But if we go back here, you can see that the keylogger has captured T, TE, TES, TEST, and then it has the full word in here. So it's literally capturing every letter I type on my keyboard. Now, let's go and test this against a page that uses normal HTTPS. And let's go to CNN.com again. Now again, in the search bar, let's just type Z-Security test and see if this got captured. Now, as you can see, it's not there, and I think it's because the page wasn't fully loaded. So let's type something else now. So I'm gonna just delete this and type test 2.2. And perfect, as you can see, we got it right here, test 2.2. So again, it's working against HTTPS, but like I said, a lot of people reported issues with it. So if you tested it, if you followed everything, if you're not seeing any errors, you can ask us in the Q&A. We'll try to help you and debug the issues. But at the end of the day, all of these plugins rely on injecting JavaScript in the loaded pages. Man in the Middle F tries to inject JavaScript in both HTTP and HTTPS, but in many cases it fails with HTTPS. If it's failing, like I said, I do cover a more reliable method in my Python course, and advanced network hacking courses. So if you're interested in that, check out the bonus lecture for links to these courses and for a comparison between all of the other courses that I teach. Also, keep in mind, this will never work against websites that use HSTS. So like we said before, HSTS is used by Google and Facebook and all of these really big and popular websites. The reason why it doesn't work against these websites because modern browsers come with a list that is stored locally with websites that should only be loaded as HTTPS. So even if we try to downgrade the connection to normal HTTP, the browser will just refuse to load that website. Right now, there is no practical way of bypassing HSTS, but I will update you as soon as there is a method to do that. In this lecture, we're going to be talking about how to inject code into the browser, into the target computer. So since we're the man in the middle and since everything flows through our device, then when someone requests a page, we can actually insert any type of code that we want into that page. Browsers can run two types of code. They can run HTML code and they can run JavaScript code. HTML code is the code responsible for the way that the page looks. So it's the code for the buttons, for the text, for the images, all of that. So it can't really be used to do anything that will allow us to gain any access to the target computer. JavaScript, on the other hand, it's a programming language that can be used to do many things, and we'll see that in future videos. In this video, we'll see how we can inject JavaScript code into the target browser. You can use the same method to inject HTML, but JavaScript is more useful. That's why we're going to use our example to inject JavaScript. So we're going to be using the same command that we always use. The only difference is we're going to insert the inject plugin. And then we have different options for injection. So there's three main options. There is the file, so you can have your code stored into a file, and you can use JS file or HTML file to inject the code stored in that particular file that you specify. Or you can use, if your code is stored online and it has a URL, then you can use that URL or that link using the JS URL or the HTML URL options. Or you can actually supply the code itself through the command using the JS payload or the HTML payload. Now, if you think of it, what we're doing right now is exactly what we did in the previous lecture. In the previous lecture, we just loaded ready JavaScript codes. In this lecture, we're learning how to inject custom JavaScript codes. Therefore, everything I said in the previous lecture applies here. So, using man in the middle F, you should be able to run this against both HTTP and HTTPS pages, and you'll see it right now in this video. But looking at the feedback, sometimes it seems like this method is not 100% reliable when it comes to HTTPS. A much more reliable method would require you to write some Python code. Therefore, it's a little bit too complex for this course, and that's why I only covered it in my advanced network hacking course and in my Python course. So if you're interested in that, check out the bonus lecture, the last lecture of this course, for information about both of these courses and my other courses that you might be interested in. With that being said, let's go ahead and test this, and I'm going to be using the exact same command that I used in the previous lectures. Instead, I'm going to remove the screen and we're going to use the inject plugin, and we're going to say that I want to inject a JavaScript payload, and then I'm going to give it the code that I want to inject between two double quotations. The code that I'm going to use is a very simple code that only displays a warning on the loaded page. So we're going to say alert, single quote, test, close the single quote, and close the bracket. The reason why I'm using this very simple code is just to test and see if we can actually run JavaScript code using man in the middle F. If you want to run more complex code, you can use the JavaScript file argument, which I'm going to show you later on in this lecture. So right now we're just testing and we're just running a very simple JavaScript code that will show a message box on the target computer. So I'm going to hit enter. And we're going to go to the target browser. Like I said, let's test it first against HTTP because it's much more reliable against that. So we're just going to go to vulnweb.com. And as you can see, we're getting a message box telling us test. Now, let's test this against the HTTPS page. So let's go to cnn.com. And perfect, as you can see, we're getting the message box right here. So the JavaScript code that we wanted is getting injected in the target browser, in the target page. And as you can see, this code is actually very simple and it doesn't do anything useful, but you can look online for more useful codes that you could run on the target computer. Now, what I also want to show you, so I'm going to do Control-C here and clear the screen. What I also want to show you is how to inject code stored in a file, because sometimes if you're actually using a useful code, it's going to be long and it's going to be hard to type it right here in one command. So I'm going to open a text editor. So I'm just going to type leafpad. So we can use this command just to open the leafpad text editor. And in here, I'm going to type the code that I want to inject in the loaded pages. Again, I'm going to use a very simple code for testing. So I'm just going to say alert. And this time, I'm going to say test2, just to know that this is a different code. So I'm going to press Ctrl-S to save it. And I'm just going to save it in my root directory. And let's call it jscode.txt. Okay, we're going to save this, quit it. And now if we actually just list the files, because I'm already in root, you can see I have the file right here. So we're going to use the exact same command like we did before. But this time I'm going to remove all of this because we're not using a JS payload. We're going to be using a JS file. And after that, instead of giving the code, we're going to give the full path to the location of the JavaScript file. And in my case, it's right here. It's in root because right now we are in root. So even if I go down and open a file manager, you can see this is the file right here. So it's in my root directory. So the path is going to be /root/JSCode.txt. So again, very simple. We're loading the inject plugin. We're telling it that we want to inject code from a file, and the location of this file is this. So I'm gonna hit enter. This will run. We go to the target. I'm gonna hit enter for this, and let's go back to vulnweb. Sorry, I went back. I didn't actually load the page, so I'm gonna refresh the page. And perfect, as you can see, the code is getting injected in the page. This is an example of injecting the code in a normal HTTP page. And let's go to cnn.com, a HTTPS page. And perfect, as you can see, it's injecting it in HTTPS pages. So as you can see, for me, it's working for both. But for some reason, I still get sometimes people telling me that they tried everything and it's not working for them. And when I tell them the more advanced method, it always works. But like I said, every time I test it, it works for me for both, for HTTP and HTTPS. And yes, like we said before, this will not work for HSTS because the browsers will literally refuse to load the page. So, using this method, like I said, you can inject any JavaScript code in any browser that is connected to the same network as you. And the cool thing about this is it works against any browser. So whether your target is using a phone, a tablet, a computer, a TV, a PlayStation, as long as their browser supports JavaScript, this will work against their browser. And in the future lectures, you'll see how we can use that to hook people to a browser exploitation framework and from there gain full control over their devices. So stay tuned. In this video, we're gonna cover how to use man-in-the-middle F against a real network. Man-in-the-middle F can be used against real networks exactly the same way that we were using it against virtual networks. The only difference is you want to make sure that you specify the right IPs, the right interface, and connect to the same network that the target person is connected to. I'd also like to go over a few points that might prevent man-in-the-middle F from working properly. So the first thing that I'm gonna do now is just do ifconfig to show you my configuration. And as you can see, I only have ETH0 right here, and it's connected to my NAT network because I configured my Kali machine to use a NAT network right here. So first of all, the first thing that you want to do before you target a real network is make sure that that's the only network that Kali is connected to. So the first thing that I'm going to do is I'm going to disconnect myself from this network. This is very important, and it's actually the main thing that seems to be interfering with man-in-the-middle F. So the attack might work, but you will have DNS issues, or the target machine will experience very slow internet connection, or they'll lose their internet connection completely. So the first thing we're going to do is we're going to disconnect from this virtual network. So we're going to go to devices, we're going to go to network, and see the check right here? That means we're connected to the network because it connects the network adapter. So I'm going to click that, and that's going to disconnect me from the NAT network. So if I do ifconfig now, you'll see that ETH0 is not connected to anything right now. So I'm literally offline in the Kali machine. I can't even ping anything. As you can see, I can't even ping Google. The next thing that we need to do is connect to the same network that the target machine is connected to. And in this video right here, I'm going to be targeting this Mac machine. So it's a real computer, it's a real physical computer connected to a real physical Wi-Fi network. And the name of the network is UPC 0460916. So this is the network that I need to connect my Kali machine to so that I can attack this computer. As we mentioned before, you can't use the internal wireless card inside VirtualBox, inside virtual machines. So to connect to a Wi-Fi network, we're going to need to use an external wireless adapter. I'm going to connect my wireless adapter right now through a USB port. And then I'm going to go to devices, USB, and connect my wireless card. That's the name of it, Atheros. Now if I do ifconfig, you'll see that I have a new interface, and it's called LAN 0, and this is my wireless card. But as you can see now, this wireless card is not connected to any network. So to attack our Mac OS machine, as I said, we need to connect to the same network that it's connected to. And to do that, I'm going to go click on this arrow. I'm going to go to Wi-Fi. I'm going to go to select network. I'm going to connect to the same network that the Mac is connected to. And I'm going to put the password. Now that I'm connected, if I do ifconfig, you'll see that LAN 0 has an IP address. And notice that the first three parts of the IP address here are the same as the first three parts of the IP address in Mac OS. So if I do ifconfig here, note that the first three parts here are the same as the first three parts here. And that basically means that these two wireless cards are on the same subnet, on the same network, and now I can use LAN 0 to target this computer right here. So if we do ARPA here, notice the MAC address now. This is the right MAC address of the router. And when we run man-in-the-middle F, this should change to the attacker's MAC address. So let's run man-in-the-middle F exactly the same way that we used to do before. So we're going to do man-in-the-middle F. We're going to do ARP spoof. We're going to give it the interface. And this time we're targeting a real computer, we're targeting a real network, and LAN 0 is connected to that network. So we're going to use LAN 0 for the interface instead of ETH 0. Then I'm going to set the gateway, and that's usually the first IP in the subnet. So it'll be 192.168.0.1. And then I'm going to specify my target, which is the Mac machine, and it had an IP of 192.168.0.19. So again, it's exactly the same command that we did before. The only difference is we're using different arguments. We're using LAN 0 because LAN 0 is the wireless card that's connected to the target network. We're using the gateway, which is the first IP of the same IP that we have. And then we're using the target, which is this Mac machine, and we've seen it to be 192.168.0.19. I'm going to hit enter and come back here. Now, as you can see, the old MAC address of the router used to be this. Now, if we do ARPA, the MAC address should change to the Kali MAC address. But as you can see now, in this case, it still didn't change. And the reason for this is because we're actually targeting a physical computer in a physical network. So this could actually take up to 1.5 minutes for the changes to reflect. So just give it some time and then check the MAC address again. I'm also gonna go and browse to a website just so that I'll generate some traffic on my computer, on the target computer, so that it'll go ahead and update its ARP table. Now let's check again. And as you can see now, the MAC address changed to the MAC address of the attacker's one. And if we go here, you'll see that man in the middle left is sniffing data and it's capturing data that's sent by my Mac OS. Now let's go to Hotmail and log in. Now I'm going to put the username as test@hotmail.com. And I'm going to put the password as 123456. And right here, as you can see, we managed to get the email, which is test@hotmail.com, and the password, which is 123456. And again, this worked against a real computer that's connected to a real network. So the main thing to keep in mind is make sure that you're connected to the same network as the target person. If that person is connected to a Wi-Fi network, then make sure you're using an external wireless adapter, and you're not using bridged, you're not using NAT, you're literally connecting through the network manager of Kali Linux. So you need to attach the wireless card and then connect from here to the target network. Also keep in mind that you should disconnect the Kali machine from the NAT network if it was connected to one by going to Devices, Network, and then uncheck this option right here. Because we want to make sure that the Kali machine is isolated. It's not connected to any network other than the target network. So right now, if I do ifconfig, you'll see that ETH0 does not have any IP addresses. The only device that has an IP address and that's connected is LAN 0. Once you're done with all of that, and if you wanted to go back to using your NAT network to target other virtual machines, or if you just wanted to get your internet connection through the host machine, so if you wanted to use the NAT network again, all you have to do is just go to Devices again, go to Network, and click on Connect Network Adapter. That'll again connect your ETH0 to the NAT network, and it'll allow you to use it as you were using it before. So if I do ifconfig now, you'll see that ETH0 has an IP address and it's connected again to the NAT network. In this lecture, we're going to talk about a tool called Wireshark. Wireshark is a network protocol analyzer. It's not designed for hackers, and it's not designed for hacking and spying on other people on the network. It's designed for network administrators so that they can see what's happening in their network and make sure that everything is working properly and that nobody's doing anything bad or doing anything suspicious on the network. The way that Wireshark works is it allows you to select an interface, and then logs all the packets or all the traffic that flows through that interface. So you're selecting an interface. It could be a wireless card, it could be a wired card on your current computer, and then it'll start logging all the information that flow through that interface. It also has a really nice graphical interface that allow you to analyze this traffic. So it allows you to filter these packets based on the protocol using them, like HTTP, TCP, and all that. It also allows you to look for certain things. For example, if you're looking for cookies, or if you're looking for posts or GET requests. And it also allows you to search through these packets. You can search through the information that's stored in the packets and find the things that you're looking for. It's a really big tool, and you need a whole course for it. So in this course, we're actually going to use it in a few lectures, just covering the basics or the things that's related to us. So the main idea here is Wireshark is not a hacking tool. It only allows you to capture the traffic that flows through your own computer, through your own interface. I'm going to use it now, and it's going to become more clear to you. So I'm just going to go to Kali, and we're going to start Wireshark. You can run Wireshark from the command prompt, or you can just go on all applications and type Wireshark, and it'll show up right here. I'm going to click that, and that's going to load the program for me. This is just a normal error. Just ignore this error. And this is the main interface of Wireshark. So first of all, you can actually just go to the file and go to the open, and in here it'll allow you to open a file that you've already captured. So for example, if you captured packets using a different sniffer, using Aerodump, or using Man in the Middle F, or using T-Shark, which is the command prompt part of Wireshark. So if you captured packets using any of these programs and you stored it in a file, you can just come in here, open it, and start analyzing that file. This is really handy because sometimes you don't really want to analyze the traffic on the fly. So sometimes you just want to capture it. Sometimes you're capturing from a small laptop, or you're capturing from your phone, and you're not even at home, you're in somewhere else doing your pen test, and then you go back home and then you want to analyze what you captured. Then you can store that in a file, and then just come here, go to the file open, and open the file that you want to analyze. So what I want to show you here is the idea that Wireshark is not a hacking tool. It's not going to capture things happening in another device. It will only capture things that flow through your own interface. So right here we can see that we have all the interfaces in my computer. So we can see that we have ETH0, we have Any, which is just Any, and we have all the other ones that some of them are created by VirtualBox. So the main one here is ETH0, which is the virtual interface connected to my NAT network. And you can see that there is no traffic flowing through this. So you can see that this is constant and nothing's happening. So what I'm going to do now is I'm just going to make this a little bit smaller, and I'm going to open my browser here. And I'm just going to go to a normal website. I'm just going to go to google.com. Now, as you can see right here, you can see the traffic in ETH0 is spiking up. So there was some traffic generated through ETH0. So if we're sniffing on this, we'll be able to capture these packets that were sent over ETH0. Now what I'm going to do is I'm going to go to my Windows machine just to prove that point, and I'm going to browse the website here, and you'll see that ETH0 will not be affected, and the traffic that's generated on this Windows machine, which is in the same network as the Kali machine, it will not be captured by the Kali machine. So if I just go to Google again here, you'll see that nothing happened in ETH0. So there is no traffic flowing through this, it's still constant, and we can only capture packets that go through ETH0. So now you'll probably ask then why Wireshark is so useful. Why are we even talking about it if we can only see things that go through our own computer? Why are we talking about it? Well, we're talking about it because we've seen there is a large number of ways that you can become the man in the middle. Now, we talked about two methods to become the man in the middle. We talked about doing that using ARP spoofing. And if we create a fake access point, then we'll naturally be the man in the middle because all the requests will be sent to our computer. So when we are the man in the middle, if we start sniffing on the interface that's used to become the man in the middle, we'll be able to capture all the traffic generated by the people that we're targeting in our man-in-the-middle attack. So if you started a fake access point, you can start sniffing on the interface that's broadcasting the signal, and you can capture all the packets sent or received to anyone who's connected to that fake access point. If you became the man in the middle using ARP spoofing, then just select the interface that you used when you launched your ARP spoofing attack. So I'm going to do this with ARP spoofing because it's quicker and easier than generating a fake access point. But again, this works in both ways. And it even works if you manage to become the man in the middle using a different method. Just make sure you select the interface that's used to launch that attack. So I'm going to do ARP spoofing. Now you can do this using ARP spoof, or you can do it using man in the middle F. So I'm just going to do it using man in the middle F. And I'm going to go and just get the IP address of this computer. So it's 10.20.14.206. So our command is going to be man in the middle F, ARP spoof, interface, which is going to be ETH0. Then we're going to specify the gateway, 10.20.14.1. And then the target, which is 10.20.14.206. So we did this command before. This will just put me as the man in the middle. It'll redirect the traffic from the computer that has the IP that's 10.20.14.206 to my computer, placing me the man in the middle. So I'm just going to run this attack quickly. Now let's go to the Windows machine and see if I do anything here, if it's going to affect the traffic in ETH0. So we'll see if Wireshark will be able to capture traffic generated by this computer. So let's write anything here. I'm just going to Google, or I'm just going to go to a different website. I'm just going to go to Bing. And if we come back here, you'll see that we have traffic being generated here. And we can see that ETH0 is actually capturing whatever that's happening in a completely different device, and a device that's not even connected to our network. This is happening because when we are the man in the middle, all the packets that's generated by the Windows device is actually being redirected to my own computer right here, to the Kali. And then Wireshark is sniffing that from the Kali machine. It's sniffing it from my own local machine. It's not sniffing it from the network. It's not sniffing it from the target computer. It's only listening on my current interface, which is ETH0, and it can capture packets that's flowing through ETH0 because man in the middle has redirected, man in the middle F has redirected the traffic of the Windows machine to flow through my computer. So again, if you're doing this with the fake access point, then just listen on the interface that you're broadcasting. If you're doing this with a real wireless network, if you're connected to your home wireless network using LAN 0, then you can just do this with LAN 0. But with ARP spoofing, you have to first redirect the traffic, then you can use Wireshark. Now this is just to show you what Wireshark is and how it works, and I just wanted to stress the idea that Wireshark is not a hacking tool. It's only a program that allows you to log packets flowing through a certain interface and then analyze these packets. So in the next video, we'll see how we can sniff and analyze packets using Wireshark. In the previous video, we seen how we can launch Wireshark, and we said that we can actually just open a file that contains packets that we already captured, and we can start analyzing them using Wireshark. In this video, I want to start sniffing packets and then generate some traffic in my Windows machine, and then we'll see how we can analyze these packets using Wireshark. So I'm already the man in the middle. As I said, you first have to be the man in the middle to use Wireshark. And then the traffic that's generated in the Windows machine is actually flowing through ETH0, as we've seen in the previous video. So before I start capturing the packets, I want to go to the options, and I just want to show you what options we can set. So first, you can see all the interfaces that you have, and you can see the traffic generated on them. And you can see ETH0 is actually generating some traffic every now and then because it's actually coming from the Windows machine, which is already in here. And now anything that we do in here, for example, if we search for anything, you'll see there's a spike coming up here because the traffic is flowing through this. So in here, you can select the interfaces that you want to start capturing on. And you can actually select more than one interface. And all you have to do is just hold the control and then click other interfaces that you want to listen on. For example, we can just click them like this. But for now, I actually only want to sniff on ETH0. Now, if we go on the output, you'll see that you have an option to store these packets somewhere. So again, if you only want to sniff and you don't want to analyze things, then you can just go on the browse and you can store the packets that you're gonna sniff somewhere, and then you can analyze them whenever you have the time at a different time. You can just open them with Wireshark like I showed you in the previous video. You can just go on File, Open, and then open the packets and start analyzing them. Now, I have ETH0 selected, and I'm just gonna click on Start. And that will start capturing packets. Anything that's going to flow through ETH0 will be captured and it will be displayed in here. Anything. I mean images, pictures, messages, cookies, anything that computer will flow through ETH0 and therefore will be captured by Wireshark. So it's not like Man in the Middle Life where it was only showing us the important information. Right here, you'll see anything, all the traffic that's generated. So let's first of all generate some traffic here. So we've already generated this, but this wasn't captured. So let's look for something. So for example, let's look for a car. We're just going to look for a car called GTR. Maybe we go on images. You can see some nice pictures. Maybe open one of them. Now let's go back to Bing. And let's go to Dailymotion. Okay, now let's try to analyze the packets or the traffic that we generated. So I'm just going to stop this. Now this is the main interface of Wireshark, and you can see that the first thing we have is each one record of this is a packet. Now you'll see here the columns. First of all, here is the number of the packet. So you have this one is number 1, number 2, number 3, number 4. In the time, you'll see the time when this packet was captured. So 0 is when we first started sniffing, and then the time increases as we go down, and it shows when these packets were captured, when they were sent basically. You can also see the source. So this is the device that the packet was sent from. And you can see that this one is not sent from our target. It's actually coming from the internet, from a server that has this IP, and it's going to our target computer, which is 10.20.14.206. You can see the protocol, so it's TCP for this one. You can see that it's ICMP in this one, and you can see that it's ARP for this. You can see the length, which is the size, and you can also see info about this packet. Now you can also notice that these packets have different colors. Usually green is TCP packets, dark blue is DNS packets, and if we go down, we should actually be able to find some of them. And you can see all of these are DNS packets. Light blue usually is UDP, but we don't have any UDP packets at the moment. And you can also see that we have some black packets, and these are TCP packets that had a problem, that had issues. Now, if you double click any of these packets, it will display more information for you here. It's the same information that's being displayed in here in the bottom. So if we just bring that down a little bit, you can see right here you have the frame, you have the Ethernet, the Internet Protocol, and the Transmission Control Protocol. And using that, you can just click on the arrow and then you'll see more information that's stored in here. Now again, if you just double click the packet, you'll get the exact same information, and you'll be able to get information about the packet that you just selected. Now what we did on the target computer so far, most of the traffic that we generated was HTTP traffic. So to get rid of all this information that's hard for us to read, we're just gonna type in here in the filters, we're just gonna type in HTTP. Hit enter. And as you can see now, that filtered all the packets to HTTP traffic only. So for example, right here, you can see that we have a post request send from our target computer to a server. We still don't know what that server is, but to a server on the internet. And when we double click that, we'll get more information about this packet. I'm gonna make this smaller here. So in the frame, you can see that the interface that's used you can see information about the packet itself. In the Ethernet 2, you'll see information about the destination and the source, so you can see that the MAC address is used. In the Internet Protocol, you'll see information such as the geolocation of the target, so we can see that this packet is sent to the United States. In the transmission, you can see information about the ports used. What really interests us is the Hypertext Transfer Protocol, and this is where you really see the interesting information in our case. So in here, you can see that the request was sent to Bing.com, and you can see that this request was searching for www, and you can see that the content type was a text. So you can get this information about each packet that's sent. So you can see that Wireshark logs everything that happens. It doesn't only log, or it doesn't only show the interesting stuff, it literally logs everything. So it contains the interesting stuff plus much more. Now if we go down, we can see that we have another post request, and if we double click that, it's probably going to be my second search, which is when I search for the GTR. And you can see here I searched for a car and it's called GTR. So again, right here we can see all the searches that we did. We can see all the URLs that the user entered so far. And if we go down, you'll be able to see all the other URLs that we visited. So you'll be able to see Google and Dailymotion as well. In this video, we'll see how to use more Wireshark filters and capture a username and a password. And also we'll see how to see the cookies of a person if they're already logged into a service and they didn't enter their username and password. So I'm going to start a new capture. I'm going to close this without saving. And I'm going to remove this filter from here. And I'm just going to go to Hotmail. And I'm going to log in with my username, which is zaid@hotmail.com. And then I'm gonna put the password, which is gonna be a random password, but it's gonna be captured. So we're gonna put 1234556. Hit enter. And as you can see now, we managed to capture traffic. I'm gonna stop this. And I'm going to look for HTTP. And we're going to look for post requests. So we can see here we have get. These packets are sending get requests. And we're going to look for something that's sending a post request. And you can see now this is the first one sending a post request. So it's being sent from the target computer to the server. So let's double click this and see what's inside it. And looking right here, you'll see that this was sent to login.live.com, but we can't see any username and passwords in this one. So I'm going to close it. And I'm going to look for the next post packet, which is this one. Again, double click it. And let's see what's inside it. Now, if we come here to the HTML form, you'll see that we have the login, which is zaid@hotmail.com. So this is what we entered. And you can also see the password, which was sent as 123456. So again, Man in the Middle Left was doing this very easy for us, and it was showing us the information easily. It was filtering the important information for us. But right here, we can see that we can actually capture anything that's sent on the network, and we can see it using Wireshark. Another thing that you can do is you can actually search through these whole packets. So you can just go to Edit and then go to Find Packet. And right here you can select if you want to search in the packet list, which is just this, or in the packet details. So we're actually going to search in the packet details. We're going to keep this narrow and wide. And right here, I've set this to string, so you can actually put a display filter if you want, but I'm searching for a string, which is just a normal text. And if we search for Zaid, it'll actually go straight to the packet, this packet, which contains my username. And again, if we just look at it here, or we can double click it, whichever is easier for you, you can see that we managed to capture the username, which is zaid@hotmail.com. Now you can do find next, and you'll get the next one. Find next, and again it'll find the next one, which actually had my password in it. So again, the search right here is really useful function that will allow you to navigate through all of these packets and find what you're looking for. Now let's start a new capture and see if we can actually capture the cookies. So I'm gonna again continue without saving. I'm gonna go to my Windows machine, and I'm gonna go to Dailymotion, which I already logged in before. And as you can see, it's not asking me to log in because I've already logged in, and it already has a name here. So I'm just gonna go to this channel. Now it's just a fake channel that I created just for this lecture. Now if we go to our Wireshark right here and stop the capture and look for, instead of HTTP, we're gonna look for http.cookie. So if we go down, you can see that right here the person got to their homepage, which is that's the username, the fake username that I had. Now if we go to the post request before that, and look at the hypertext, you can see the cookie that was sent to authenticate that person. So if you use, you can just download a plugin for your browser and inject these cookies into that browser. You'll be able to log in to that username, to that account, without using the password, the same way that the user entered. Again, I'm just doing this to show you that Wireshark can be used to do all of the attacks that we did before, plus much more, because basically it can capture anything that flows through our device. So any request sent or received to or from the target computers will be flowing through our interface, and then Wireshark will be capturing anything, regardless of whether it thinks it's important or not. It's going to capture everything. So it's a really, really handy and useful tool. Now, from the previous lectures, we know once we connect to a network, it's game over, because once connected, we can run an ARP spoofing attack to redirect the flow of packets so that they go through our computer. This allows us to become the man in the middle, and once we're the man in the middle, we can run so many dangerous and effective attacks. So we can spy on all the users, steal their passwords, redirect them to different websites, and this is all just a small taste of what you can do. You'll actually see us build on this in the client-side attack section, where we're going to completely hack into computers connected to the same network as us. And if you go and do my advanced network hacking course, then you'll see more advanced attacks that'll allow us to do so many cool stuff on the network. And again, all of this is possible because once we connect, we can run ARP spoofing and become the man in the middle. Now in this section, I actually want to show you another method that'll allow us to become the man in the middle. And once we're the man in the middle, we'll be able to run all of the attacks that you've seen so far and all of the other man in the middle attacks that you'll learn in the future. So let's go back to the first diagram that we learned in this course. When we were talking about how networks work in general, we said the only device that has access to the internet is the access point, and whenever a client wants to access something, they send the request to the access point goes to the internet, gets the response, and send it back to the client. Now, what if we replace this access point with our hacker computer? So what if we can use our machine to create a Wi-Fi network that actually has internet access, so people will actually try to come in and connect to our network to access the internet, and then when they connect to our network, by default, we will be the man in the middle because we are the router. So we won't really need to exploit anything. We are automatically the man in the middle, and the clients will automatically send us any requests because they want to access the internet, and we will see these requests, obviously, go to the internet, get them what they want, and give it back to them. This way, we'll be able to launch all of the attacks that I showed you previously without the need to exploit the ARP protocol, so without the need to run ARP spoofing. All we'll have to do once our network is running and we have clients connected, we can just start sniffing using Wireshark or using man-in-the-middle-F. So, for this to work, you need a computer, and we already have our hacker computer with Kali Linux. You also need internet access, and you need a wireless device that's going to broadcast the Wi-Fi signal and tell all the neighboring devices that I am a network, you can come in and connect to me. So, you will need, first of all, an interface that has internet connection. This interface, it can be a Wi-Fi interface connected to the internet, it could be an Ethernet interface connected to an Ethernet network, it could be a 3G or a 4G dongle, and it even can be a virtual interface, and this is what I'm actually going to do. It's going to be my ETH0, the virtual interface that is connected to my NAT network. So this can be any network device as long as it has internet access. The next interface that you will need, like I said, it's gonna have to be a Wi-Fi interface because it needs to be able to broadcast the signal for the network. And you can't use any Wi-Fi interface. This interface needs to be able to act as an access point. So it needs to be capable of acting like a proper access point, like a router. Now, all of the Wi-Fi adapters that I recommend support this mode, and I've already included a video in the resources before when I first spoke about wireless adapters, but I'm also going to include this video in the resources of this lecture. So if you're going to buy one, or if you're not sure how to pick the right one, then check out this video. It should be helpful for you. So once we have this set up properly, we can use our computer to start an access point, and it's going to act exactly like a router. So people will be able to see the network when they look for Wi-Fi networks, they'll be able to connect to it and get internet connection. But when they connect, they will have to send us all of their requests because we are the router, we are the access point, so by default, we will be the man in the middle. Therefore, you'll be able to execute all man-in-the-middle attacks that you learned so far and any other man-in-the-middle attacks that you will learn in the future. So basically, ARP spoofing is one method of becoming the man in the middle, and what I'm going to show you right now is another method of becoming the man in the middle. Now, you can see that in order to use our computer as an access point, we need a number of components to be configured properly. So first of all, we need our wireless interface to broadcast the signal as if it's a real network. This will allow other clients to connect to it, but that's not the end of the road. The wireless interface needs to know when these clients are requesting websites. It needs to be able to forward these requests to the other interface that is connected to the internet. Then again, it will need to be able to know when the responses come back and forward all of this to the right client. Now you can configure all of these things manually, and I actually cover this in my advanced network hacking course, and I cover a lot of advanced things that you can do with the fake access point, like launching an evil twin attack, hacking into WPA2 Enterprise, and so on. But this would take at least 30 lectures, and this is not a network hacking course. This is a general ethical hacking course. Therefore, that would be out of the scope of this lecture. If you're interested in learning how to do this manually and how to run advanced attacks using the fake access point, then check out my advanced network hacking course in the bonus lecture, the last lecture of this course. For now, for this course, I'm going to show you a great way of quickly creating a fake access point that will allow us to become the man in the middle, similar to what's shown in this diagram. The tool that we're going to use is called Mana Toolkit, and it's basically a set of tools that allow us to automatically create a fake access point, automatically sniff data, bypass HTTPS, and so on. So the tool comes with three main start scripts. So the first one, start now upstream, will allow us to start a fake access point with no internet access. So this is not really useful for us, and I will not use this in this lecture. The next one is start NAT simple. This will start a fake access point with internet access. The third one, start NAT full, will start a fake access point with internet access, and it will automatically start sniffing data and bypass HTTPS. Now I actually always use start NAT simple. I never use start NAT full because this fails a lot of the times, and we already learned how to start sniffing and bypass HTTPS using man in the middle F. So you can always start NAT simple. This will start a fake access point for you with internet access, and then you can open another terminal window, use man in the middle F exactly as I showed you before, and you'll be able to sniff data and bypass HTTPS. You can also use Wireshark if you want to sniff the data and analyze them, again exactly as shown before. Now in the next lecture, I'm going to show you how to use Mana Toolkit to create a fake access point with internet connection. Now before doing anything, I want to show you the network settings of my Kali machine. So I'm going to select it here. I'm going to go to Settings, Network, and as you can see, it's set to use a NAT network. So now if I go to my Kali machine and do ifconfig, we'll see we have an interface called ETH0. This interface is a virtual interface created by VirtualBox because we set this machine to use a NAT network. You can also see that this interface has an IP address, which means that it is properly connected to this NAT network, and it will provide the Kali machine with internet access as long as my host machine right here has internet access. So now on my Kali, if I go and let's say if I just go to bing.com on my browser, you'll see that I can successfully go to the website because Kali is connected to the internet through this virtual interface that is called ETH0. Now, if we go back to our diagram that shows what we need to create an access point, you can see that we need an interface that is connected to the internet. We don't care what type of interface this is, as long as this interface has internet access. So in our example, we're going to be using ETH0 to provide our fake access point with internet access. The other interface that we need, we said that this needs to be a wireless adapter that is able to act as an access point. Again, if I go back to the result of my ifconfig, you can see I already have a wireless adapter connected to this computer. It's called LAN 0. Keep in mind that this is in managed mode. It's not in monitor mode, and it is not connected to anything. So you can see it does not have an IP address. This is very, very important. It needs to be, first of all, in managed mode, and second, not connected to any network. So even if we go at the network manager in here, you can see we have wired connected. This is my ETH0, and Wi-Fi not connected. Once we have everything configured properly, we can go ahead and start the access point. But first, you'll need to install Mana Toolkit because it does not come pre-installed in Kali. We can install it using apt-get, just like Terminator and other tools. So all we have to do is just do apt-get update to update the sources. Then apt-get install Mana Toolkit. Now I have it installed, that's why it's telling me Mana is already installed. But if it's not installed, this command will install it for you. Once you have everything installed, you're ready to use Mana, and before we started, we should modify its settings. Mana's settings are stored in a text file. So to edit the settings, we're going to open this file and edit it using LeafPad, which is just a text editor. So I'm going to type LeafPad, followed by the location of the file that we want to modify. And the settings file for Mana is stored in etc mana toolkit host apd mana.conf. So all we're doing with this command is we're using a text editor called LeafPad to open a file that is stored in this path. So when we hit enter, you'll see we have the text editor here opening the file for us. And all of these are the settings that you can modify for Mana. You can actually get a full list and a full description of all the settings that you can modify in this link. But we don't need this for now. The main thing that you need to modify is the interface. This is the interface that you want to use to broadcast the signal. So basically it is this component, and in my example this is going to be LAN 0. This is my wireless interface, so I'm keeping this the same. The next thing that you might want to modify is the SSID. This is the network name that will appear when people look for Wi-Fi networks. I'm going to keep this as internet, so when people look for networks, they will see my fake access point under this name. So I have nothing to save right now, but if you modified anything, make sure you save the file from File, Save, and then close it. And the next file that we'll need to modify is the start script. This is the file that will actually start Mana Toolkit for us. Again, we're going to use LeafPad to open and edit this file. So we're going to type LeafPad followed by the location of Mana's start script, which is in user share Mana Toolkit run mana start not simple.sh. Now in this file, there are two main things that you need to modify. The first one is the upstream interface. This is the interface that has internet access. So this is this component right here. And as we've seen before, this is ETH0 in my case. So I'm going to leave this the same. The next one, the PHY, is again the interface that is going to broadcast the signal. So in my example, this is my wireless adapter and it is called LAN 0, not LAN 1. So I'm actually going to modify this to LAN 0. Then I'm going to save it, Control S, and quit it, Control Q. And that's it. We're ready to start the fake access point. And like we said before, we're going to be starting it using this script right here, the start not simple. That's why we modified it. So all we have to do is I'm going to copy this because that's its location. So in order to start it, because this ends with a .sh, we're going to do bash followed by the location of the script. So when we wanted to modify it using a text editor, we used a program called LeafPad followed by the path of the file. Right now, we don't want to modify it. We want to execute the code inside it. The code inside it is a bash script code. That's why we're saying I want to run this file using bash. Now I'm going to hit enter. And as you can see, it's telling me that the access point is enabled and I can press enter to kill the access point, so to exit it. Now, sometimes the first time that you run this script, it will not work. It will actually give you an error. So it's a good idea to actually just run the code again, literally the same command. If it fails, if it complains about a specific error, just run the command again and it might work. If it didn't work for the second time, then ask me in the Q&A section and we will respond to you and help you fix this issue. So now let's go and try to connect to this network and see if it actually works. So right here I have a Windows machine. It's another virtual machine, but I have another wireless adapter connected to this machine. Do not test this from your host machine because the fake access point is getting its internet access from the host machine through the NAT network. So if you test this network from the host machine, the network will not work. So either test it from another virtual machine with another wireless adapter, or if you don't have another wireless adapter, then you can test it from your phone or from another laptop or any other computer within range. But do not ever test it from the host machine. So right here, I'm going to search for networks to connect to. And as you can see, I have a network called Internet. It does not use a password, so I'm just going to connect to it. As you can see, I'm connected now, and I'm going to open Firefox just to check if I have internet connection. So I'm going to go to bing.com. And as you can see, bing.com is loading, so now I actually have internet access. So now anything I do on this computer will have to be sent to the access point. If I want to access any websites, if I enter any passwords and usernames, everything is gonna go to the access point. And the access point is the hacker machine, so the hacker machine is already the man in the middle. So now you're at the same position that you would be after running an ARP spoofing attack. So you can go ahead and use Wireshark to sniff packets and analyze them, or you can go and use man-in-the-middle F exactly as I showed you before. The only thing that you need to keep in mind when using Wireshark or man-in-the-middle F or any other tool, you need to set the interface to the interface that is broadcasting the signal. So this is the interface that you set in the PHY option, not in the upstream. So in my case right now, this would be LAN 0, not ETH0. Also, if you're going to use man-in-the-middle F, theoretically, you wouldn't need to use the --ARP --spoof argument, but I noticed that the tool will not work unless you add that argument, so you can add it in and you'll see that it'll work exactly as shown before.